Tranquility Base here. The Eagle has landed. Rocket Tranquility, we copy you on the ground.
New possibilities are opening up for scientific cooperation between countries.
1-0-0. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery Roger, go for deploy.
Everybody in the shuttle program, the crew is go for launch.
Hothead, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good morning. I'm Faith Mackey with NASA's Office of Communications, and thanks so much for joining us. Participants in today's press conference will include NASA Administrator Bill Nelson, NASA Associate Administrator Jim Free, Program Manager of the International Space Station Joel Montalbano, as well as NASA's Commercial Crew Program Manager Steve Stich. After brief opening remarks from each of our speakers, we will gladly take questions in the room and over the phones. Now we'll have our opening remarks from Administrator Nelson.
Well, we're here for Crew 8, which is now the 9th launch of Crew. The first, Doug and Bob, having done the test flight. And this mission to the ISS really has a lot of exciting science that they are doing. There are some 200 science experiments. And a lot of the stuff dreamed of in the old days is just coming to fruition. The use of protein crystal growth, the medical research into the use and growing of stem cells in microgravity. All of these breakthrough research, not only toward helping find cures for cancer, but things like bone loss, osteoporosis, even some things having to do with medical research with regard to the brain. So I think we are at the point that we are just seeing the amount of time that a crew is able to dedicate themselves to the science experiments. We're finally seeing those experiments utilizing the property of microgravity coming into its own. I can get into detail on some of this, but just last week, as a matter of fact, we did a direct link up to talk with the crew about some of their scientific research. There are obviously a lot of other things that are going on here. We had the third private astronaut mission, and that increasingly is giving us science that they are conducting on the station. We put up a major scientific instrument, satellite spacecraft called PACE. PACE is very much a part of us understanding what is happening real time to the Earth. As we now have some 22 instruments up there in space that are measuring very specifically things. In the case of PACE, looking at how aerosols are affecting the climate, how dust particles are affecting, how plankton in not only the oceans but the freshwater are affecting the environment and the climate as we continue to get a very precise 3D understanding of exactly what's happening to our Earth. And then, of course, this past week, and as we speak, Intuitive Machines is still transmitting. They are going to have a press conference at 2 o'clock this afternoon. They can give you the specifics from their standpoint, but I can tell you that we are getting data from all 6 NASA instruments. And oh, by the way, one of those instruments was a LiDAR. And lo and behold, NASA came to the rescue, because when Intuitive Machines LiDAR went out, the ability to get down from lunar orbit and to land, within 2 hours, the Intuitive Machines engineers figured out that they could get a patch to our NASA LiDAR instrument, and that's what successfully brought Odysseus down to the surface. So let's don't forget the remarkable 72 flights of the little helicopter on Mars, Ingenuity. It was like we were going to be lucky to get 5 flights, and that's all we expected. And here we ended up getting 72 flights, and it actually became a scout for the rover Perseverance on the surface of Mars. So that's my summary, Faith.
Thank you, sir. Now I'll pass it over to Jim Free.
Thanks, Faith. Good morning, everybody. What a crazy, exciting time in space right now. And it's all, of course, rooted in NASA's mission of exploring the unknown in air and space. I think you see that on this mission and the ones that the administrator highlighted, innovating for the benefit of humanity and inspiring the world through discovery. I think the 4 individuals on the screen behind me exemplify that, and I'll talk about more them in a second. I'll add to the administrator's discussion about exciting things beyond PACE. X-59 unveiling in our Aeronautics Research Mission Directorate was a tremendous thing for me to be part of, and research that is going to change and hopefully enable that space over land to fly supersonic. I think I want to talk for a second about the Artemis campaign, the Commercial Lunar Payload Service initiative that the administrator talked about with Intuitive Machines. That first flight, the first flight of the Astrobotic mission under CLIPS, we learned along the way. We got science. We're getting science on Intuitive Machines. We got science on Astrobotic. So we're starting our exploration of the moon with Artemis. We just finished our recent architecture concept review, where we're laying out more detail of our path to the moon and on to Mars. And of course, Artemis 2 well underway. Our crew was out on the USS San Diego this week doing recovery tests with our Navy partners and our exploration ground systems from right here at Kennedy. The hardware for Artemis 2 continues to process well. The crew module, we talked about some of the challenges in the crew module with the battery and the heat shield. We continue to make progress on both of those. Tough technical problems, but working through. The core stage for Artemis 2 is going to ship this summer right here to the Kennedy Space Center. And work on the Exploration Ground System mobile launcher. For those of you that are here, you can see that mobile launcher out at pad 39B as we continue to work to refurbish and test that. Artemis 3, our first landing mission, the work for that on the Space Launch System core stage, the welding is going well, and on all the pieces, working through the technical challenges that we have there, but going well. Our spacesuit development under Axiom for Artemis 3 had a recent run in the Neutral Buoyancy Lab at Johnson, and the crew module just a few miles from here for Artemis 3 continues to go well through its assembly. And our human lander, we talked about big milestones technically this year with our service provider there in SpaceX. Our next big milestone is the propellant transfer mission, so we're looking forward to that next Starship launch. International partner-wise, we brought on the United Arab Emirates to provide the airlock for Gateway, a huge capability that will be added to Gateway and another international partner. on the program, and then Artemis Accords with recent signatories by Uruguay and Greece. Today we're here to focus on this incredible Crew 8 mission and those 4 individuals that I talked about, I mentioned with Matt and Mike and Jeanette and Alexander. Their mission will continue to further our understanding of how humans learn and behave in space and their bodies respond. Our scientific exploration from station is incredible. We heard a great briefing at the Flight Readiness Review on eco-stress, which is a canopy temperature measurement to understand how we're affecting climate. And it's all critical to our lunar exploration. We need all of these to come together to understand how people and technologies and systems will behave when we go on longer duration missions. I want to personally thank the crew for their work, their sacrifice that they've made of their time to train and be ready for this mission, and certainly what they're going to do on orbit. And of course, our focus is always on flying safely. That is decisions that we leave to our technical teams, and that you'll hear from Joel and Steve here in a moment. But ultimately, that's our measure, is how safely we fly, and we take care of the people that have been entrusted to us. All right, next month we'll launch an astronaut from Russia on a Soyuz, and then in April we're targeting the first flight of Starliner. So 7 crew members going up, 4 coming home, all of which we need to put their safety first, especially when we look at the new vehicle with Sonny and Butch looking at that, and I know Stich will be taking care of them as well. So I'm also excited. Next week we have astronaut graduation down in Houston, which will be the next set of crew members that will be in line to support the great missions that we're planning. I do want to take a minute to congratulate Joel on his new role as the deputy in our Space Operations Mission Directorate, an incredible leader for the space station program, and Dana Weigel will follow in Joel's footsteps. Dana's been Joel's deputy, and she's going to do tremendous in her new role as well. So with that, Faith, I'll hand it back to you.
Thanks, Jim. I'll now pass it over to Joel Montalbano.
All right. Well, thank you guys for joining us today. As everyone knows, we're looking for a launch early Friday morning Eastern time. That sets us up for a docking to the forward part of the International Space Station early Saturday morning. Right now we're targeting 7 a.m. Eastern time. We'll have the hatch opening after we do leak checks. That process will take about 2 hours. So about 2 hours after docking, we'll have hatch opening. The Crew 8, Crew 7 handover will take about 5 days. We'll have 5 dock days of handover activities, after which we'll start watching weather and look for a landing opportunity for Crew 7. Crew 8 will stay on board the International Space Station until late August. As the administrator said, over 200 experiments in science and research, technology development, and commercialization of low Earth orbit. Soon after the undocking and landing of Crew 7, we'll turn our focus to the SpaceX Dragon cargo mission number 30, which will launch a few days after that. That vehicle will stay docked to the International Space Station about 30 days. We'll also have, as Jim mentioned, a Soyuz launch March 21st, and then the Soyuz landing on April 2nd. As we prepare for these missions, we're always looking at the space station systems. And I do want to give you an update. We've been watching the leak rate of there's an area in the aft end of the International Space Station that we've seen a leak. On a small leak, we have saw that leak increase about a week before the recent Progress launch and docking. And so the teams have been watching that. Currently, the hatch is closed to that area. It's not an impact to Crew 8. But I didn't want anybody to be surprised if they heard about that later, and wanted to know that the teams are watching it. We're working with our Russian colleagues on the next step. Not an impact right now, the crew safety or vehicle operations, but something for everybody to be aware of. With that, I'll hand it back over to you, Faith.
Thanks, Joel. And last but not least, Steve Stich.
Yeah, thank you, Faith, and thanks to all of you for being interested in human spaceflight and for following the Commercial Crew Program. You know, we're very proud and excited to be part of our space endeavors and to support Joel and all the great science that happens on the International Space Station that the administrator talked about. That would not happen without our flights and without our crews. We're excited to be getting ready for the Crew 8 launch, still on track for 12:04 a.m. on March the 1st, our first launch opportunity. I talked after the flight readiness review about a couple of backup opportunities. It's been a busy time down here. I mean, the crew's been down. They got in Dragon on Monday evening and checked out all the systems of Dragon. We rotated the seats in Dragon, got to go through all the displays, practice the countdown, closing the hatch, closing out the vehicle, and doing some pressure checks. That all went really well with Dragon. The next day, Tuesday, we actually hot-fired the Falcon 9 first stage. All 9 engines did the normal 6-second static fire time. We did see an indication on engine 6 on one of the components that was a little out of family with what we had seen in previous flights, so we swapped out that component. The component we removed has been sent to Hawthorne for some checks and to make sure it's okay. The new component is installed and is working just fine. We've done checkouts of that, and so we're really ready to go fly. We are watching the weather very carefully. The launch weather looks really favorable for Friday morning's early launch. I would say the abort weather is what we're watching very carefully. We have to have weather along the East Coast ground track to be acceptable for launch, and so that weather right now is not looking as favorable as we'd like. We'll do another weather briefing tonight, and then we'll take a look at the weather again. So we have several opportunities, and so we're just taking it one step at a time relative to weather. We will have the launch readiness review this evening at 8 p.m., and so we'll close out some of the final items coming out of the flight readiness review that we talked about on Sunday, and so those are all on track for closure. Really excited to go fly Endeavour. This is the 5th flight of Endeavour, so we've taken a lot of extra time. It's our fleet leader to go through all the systems, in particular the prop system, just to make sure we're really ready to go fly and excited to go do that. As Joel said, on the heels of Crew 8 for us and Crew 7 return, we have the CFT, the crewed flight test mission, the flight tests with Butch and Sunny. We're excited about that flight. Over at Pad 41, ULA, the United Launch Alliance, is preparing the rocket for launch and installed the solid rocket motors and going through the processing for that vehicle. In the factory over at Boeing, the Starliner spacecraft is pretty much closed out. We've loaded the fluid for the cooling system. The next big event really is to load propellant on the crew module and propellant in the service module, and that'll happen in mid-March. And what we're doing with the 2 flights is we're watching our flight and the readiness of freeing up the port on station, and we're going to work hand in hand with Joel on the right decision points to go fuel Starliner. As Joel said, it's a busy time, so we may adjust the date. Right now we're targeting the crewed flight test in late April. I would say in Commercial Crew we're also proud to support exploration and do what we can to help the Artemis program. We're going to fly an Orion drink bag for the first time for the crew to use on Crew 7 return, just to test that technology out ahead of Artemis 2. And then if you look ahead at the Boeing vehicle, the NASA docking system that we fly on the Starliner vehicle is the same technology that Orion will fly for docking for Artemis 3 and future flights. And then also the Starliner parachute system is really a derivative of the Orion system. So as we fly our flights, we get data for exploration as well. So we're happy to be here, and I'll turn it back over to you, Faith.
Thanks so much. We'll now go ahead and open the floor for questions. I ask that you please identify your name, your outlet, and to whom your question is directed. We do have people in the room and on the phone lines, but we'll start with any questions that we have in the room, and please wait until you are handed a mic.
Hi. Hi, thank you. Ken Kramer, Space Up Close. Thanks all for being here. What a great panel. Could ask everybody a question. And Joel, congratulations again. But let me focus on Bill and Jim right now. I'd like you to expand upon IM-1, the results, how important that is for commercial lunar landing and for Artemis, paving the way to returning our astronauts. Tell us more about why this is so important and what's the future? Is Viper going to launch by the end of this year? Thank you.
Remember that you're going to get details at 2 o'clock this afternoon. And the details appropriately should come from Intuitive Machines. from NASA's standpoint, all of these commercial landing missions, CLIPS, become scouts for us before we land on a very hazardous part of the moon. The South Pole is pockmarked with craters, and because of the angle of the sunlight, those craters are constantly shadowed in darkness, and therefore the landing has to be very, very precise. And so all of the data that we are going to get from these CLIPS missions before Artemis 3 ever touches down is going to be extraordinarily valuable. And each of these NASA instruments of the 6 are all a part of getting additional data that we need before we have humans land on the South Pole. Jim?
I think you said it well, sir. I'll add one example. One of the payloads on Intuitive Machines and what we hope to learn on future ones has to do with plume surface interaction. And that's important to us of how the regolith behaves as a lander goes down. Obviously, it's size dependent, how much rocket exhaust you're throwing at the surface. But that's very important to us as we think about where we're going to put our future Artemis elements. We have to be careful of the proximity of where our lander is going to come down so that we don't contaminate, for instance, a habitation element. But as that distance grows, that means the crew either has to be transported there or they have to walk. So that trade is important to us in the architecture, and it's informed, as the administrator said, by these early missions, for one example of a technology.
And by the way, it's cheaper. Now we leverage the few little nickels that we have by getting the commercial industry to foot some of the bill. And so we put down incentive money to the corporations, and then they take it from there. And oh, by the way, what's the incentive for them? They've got seed money, and then what they are doing is they're producing a lunar economy as they continue to grow and continue to experiment and invent. And a good example of how we are sharing the cost of the entire exploration program is we go back to the moon not only with commercial partners, and that's certainly true in the Artemis program, but we go back with international partners. And there are substantial international investments in each of the steps as we go back to the moon. So all of this is leveraging what we are able to get out of the Congress and to do all the more with.
And Viper, could you just talk about Viper? Will it launch this year, or will you need more time?
I think we're looking at how the testing, the assembly and testing of Viper is going together, also looking at the impacts of what we're learning on CLIPS and how those landers are coming together. I think we'll probably be able to share more about that in the near future. But right now, those two competing development, I mean, it's a challenge to get there, and we want to be sure. This is a high dollar value mission, and we want to find the success, because just like the other CLIPS missions, Viper's important to us to understand the volatiles and where we're going to go and where the payback is to land once we get there.
And oh boy, if we find water in quantities, it's Katie bar the door.
All right, any more questions in the room before we switch over? Sure.
Hi, Brett Tingley, Space.com. This is a question for Steve Stich. During the flight readiness review, we heard that there's some discussion of Dragon potentially being pushed to 15 flights from 5. I'm wondering, after Endeavour comes back, what specifically will you be looking at to help make that determination, as it being the Crew Dragon that's made the most flights? And do you have any kind of a timeline for when that requalification might be?
Yeah, good question. So we are right now embarking upon what we call, our extended Dragon certification. We're getting data. SpaceX is in the middle of doing extra qualification on every single component. For example, if you have a fan and you're going to now need to, run that fan longer and fly it more times, SpaceX is doing those kind of things. We're working on that this year and probably next year to try to see how long we can go fly Dragon. We don't have specifically what we'll look at yet. One of the things we're doing as we go embark upon this activity is to try to figure out when Endeavour comes back in the August timeframe, what specific systems do we want to look at? Do we want to go look at certain parts of the structure that have been exposed to the space environment up and down for many years? Do we want to look at some of the propellant tanks? Do we want to look at some of the propellant lines? A lot of components come off every flight, and so we already can look at those. The nose cone comes off, the heat shield comes off, the panels that are the base part of the structure comes off. We need to think about, do we want to take the docking system off? That typically doesn't come off. The thrusters come off every flight. So we're in the middle of that right now, figuring out what kind of components do we want to look at. So.
Thank you. We'll get to your question, but did want to go ahead and take one from the phone lines. We do have a question from Gina Sinceri from ABC.
Yes, I missed the details on the leak. Could you give me a little more information about that, to position the volume?
Okay, so this area is in the aft end of the Russian service module. It's where we attach the progress to the vehicle. And so I'd say that area is about 3 feet or so in length. It's we've been watching this for a while. This isn't this area has had some leaks. In fact, we've repaired a couple cracks in that module part, and we've done some other areas of interest. So we're continuing to watch that, but that's where we saw it. When we close that hatch, the rest of the space station, the rest of the Russian modules, the rest of the U.S. modules, European, Japanese, everything is solid. And so we know that the area of interest is in that aft end, and that's something that we're watching.
Thank you. We'll move to our next question on the phone, Christian Davenport from the Washington Post.
Hi, thanks for doing this. Chris Davenport from the Washington Post. I guess this is for the administrator or maybe Joel, because I have to do with the station. But there have been reports that Russia could possibly deploy a nuclear weapon in space. John Kirby at the White House has said this would violate possibly the Outer Space Treaty. I'm just wondering, how much of a concern is this for NASA, given the threat it could pose to the ISS? And wondering if you had any conversations with the Pentagon or even your Russian counterparts about it, and how it might affect NASA's relationship with Roscosmos going forward. Thank you.
Christian, it does concern me because naturally, if those newspaper reports are true, then we would be concerned about the safety of our astronauts on the International Space Station and our foreign astronauts, which would include the Roscosmos cosmonauts. We would be concerned as well about our satellites, NASA satellites. With regard to your second question, to what degree do we have discussions about this? I can tell you that it's our responsibility at NASA to be aware of most everything that's happening when it comes to the safety of our crew, and we will continue to have that. On any details with regard to it, the thrust of your question, you need to refer that to the White House and Admiral Kirby.
All right, we'll do one more phone before switching back over to the room. We have Marcia Dunn from the Associated Press.
Yes, hi. If I might also ask the administrator about the Odysseus lander. Sir, I'm not sure a sideways landing would have been considered a success during the Apollo program, nor would a sideways landing by a future Starship on the moon. The Odysseus mission has had its share of challenges. If you could please put all these issues, challenges it's had into context on how America should view this mission, maybe a partial success? Thank you.
Odysseus is a success. From NASA's point of view, there's a big difference on landing a crew and landing a bunch of instruments. And where the instruments, now we are in the Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, we are in the 6th day of what was planned as an 8-day mission. And we're still receiving data. So from NASA's point of view, and we're getting data from all 6 of our instruments, and they'll tell you at 2 o'clock this afternoon the rest of the payloads on there and what data they're getting. I consider this, from NASA's perspective, a success.
All right, gentleman in the back.
Stephen Young with Spaceflight Now for Steve Stich. You mentioned that the abort weather wasn't looking great. Could you maybe quantify that? Is it marginal no-go or solidly no-go? And also, could you talk a little bit about how you calculate the abort go, no-go weather? I understand it's pretty complicated, but if there's a way of you explaining that whole process across the entire downrange track.
Yeah, two good questions. First, I would say the abort weather, whether it's going to be acceptable or not, is really based on a couple of weather systems that are coming through. There's kind of a trough that's moving through, and it's really, we're looking at the timing of that trough and where it sets up and where it is relative to the staging location in particular. At staging, we look at that location because if you think about all the events that have to happen at staging, when the first stage, the 9 Merlin engines shut down, there's separation and the MVAC engine has to start. It's one of the more complicated times during ascent. Relative to how we do abort weather, we basically have a number of points all across the ascent ground track from the launch pad all the way to orbit insertion. And for each one of those points, we look at a kind of a weighted risk. Like I talked about, if you look at the rocket early when it comes off the launch pad, there's a lot of steering that has to happen. It's very dynamic all the way up through when the engines throttle down, and then you have staging. So we weight that as a higher risk area, and we want to make sure that the weather is more acceptable in those areas. Same thing at staging, and then other points are weighted a little less. And so we basically sum all this up and look at that aggregate risk and then compare it to the criteria. And that's sort of how we do the abort weather. It's not easy. Every flight is a challenge. We'll watch the weather carefully. We'll have the weather briefing this afternoon, or I guess it's really this evening, and then we'll make the right decisions and we'll go fly when we're ready. So.
And as far as how you would rate it currently, is it marginal or?
I would say it's marginal right now based on the forecast. Yeah.
And when would you make a decision? Would you make that abort weather decision early, or would you take that right down to the last minute?
We'll have to look at how this trough is progressing and where this high pressure system that's causing the winds. Right now, there's a wind criteria at staging, and really the winds are what's mostly out of limits at staging. The vehicle is only designed to handle a certain amount of wind, and so we'll go look at the weather tonight and make a decision. Do we push the launch 24 hours at that point, or do we take it down further? And that's really going to be based on the weather models and the prediction of this trough, and then sometimes we'll take it all the way down to day of launch, and we just have to look at the data a little bit more. We had our first look, I guess it was last night, better look tonight with better models 24 hours out.
Thanks for your question. Back over to the phone, we have Jeff Faust from Space News.
Good morning. Quick question for Joel to follow up on the ISS leak. Can you quantify how much of an increase in the leak rate that you've seen recently, and what is NASA and Roscosmos doing to potentially address that leak issue? Thanks.
Okay, so right now it's a little over 2 pounds a day, and before about a week or so before progress, we were tracking about 1 pound a day. And so what we're doing is, as you saw, when we had the progress operations, We kept that hatch closed for about 24 hours after the progress dock, just to let everything dampen out and go ahead and watch and see if anything's changed. Nothing changed. We opened that hatch. We had the Russian cosmonauts went in there and emptied the majority of the cargo in the Progress vehicle in a little less than 5 days, and then we closed that hatch. So right now that hatch is closed. It's expected to be closed until early April, and we're working with our Russian colleagues on the next steps and kind of what we're going to do. You know, when's the next time you open it? How long do you want to keep it open? Once you go in there, what do you want to look at, et cetera, et cetera. So those are the steps that we're working with our Russian colleagues.
Next on the phone, we have Jonathan Seri from Fox News.
Yeah, thanks so much for doing this. My question is for Steve Stich. You had mentioned weather concerns regarding the East Coast ground track. If you could go into a little more detail, what is the ground track? Is it multiple locations? How does it work? What type of weather does it require? Thank you.
Yeah, good question. So the vehicles that we've designed, both Dragon Falcon 9 and Starliner Atlas, have the ability to execute an abort all the way from the launch pad to an orbit insertion. And so to execute that abort safely, the vehicle has to have weather under the ground track that's acceptable in terms of the sea state, so what the wave height is and the motion of the waves. And then, as I said, winds and rainfall rates, and then also no lightning in the area. And so, again, we look at every single point along that ground track. We have about 60 points we look at, and the ones right now that cause us the biggest concern are right at the staging location. So if we had an anomaly at staging and we had to separate and land, the winds right now at that staging location where Dragon would land are a little bit outside of the limits, and so we'll watch that carefully. And again, as weather patterns move a little bit, and the timing of the weather pattern can be really important for what the magnitude of those winds are, and so that's really what we're dealing with at this time.
Thanks. So now we'll take Richard over the phone from the Orlando Sentinel.
Hi, thank you for taking my question. This is really for Steve and Jim. I was curious about the percent of the astronaut corps that are actively training with Starliner. I mean, at this point we have Starliner 1 potentially next year. And I know on a previous call it was mentioned that Crew 10 was targeting the spring. I didn't know if that was misspoken or Starliner was in line to potentially be the early mission next year, or if it had really fallen to the end of 2025. Assuming everything goes well. That's it. Thank you.
Steve, you want to start?
Yeah, I'll start. Right now with Starliner, we really have two crews primarily in training. Obviously, Butch Wilmore and Sonny Williams for CFT. Mike Fink is the backup astronaut for that flight, and so they've been in training for quite some time. And then we also have the Starliner 1 crew that's been training for that mission. Right now, that mission is scheduled for, we have that scheduled for February of 2025, and right now we have the Crew 10 mission kind of at the same time. And so our plan is to really watch the progress of how Starliner 1 is progressing with the hardware build and the certification products. If you remember, just like we did for Demo 2 to get to our Crew 1 flight, for that test flight for CFT, we have a certification process that we go through after that test flight to get to the first Starliner 1 mission. And so we'll do that toward the end of this year. We'll also watch the performance of the crewed flight test and how well does that mission go, what kind of learning was there on that mission, and then we'll have to make a decision. So we can carry it down a little bit further in terms of processing both at the same time and then make a decision toward CFT.
And I just add, the crews are part of the Johnson Space Center under Vanessa Weish's leadership, and part of the Flight Operations Directorate under Norm Knight and the Chief of the Astronaut Office, Joe Acaba. And that astronaut office is broken up into various branches that support different vehicles, operational missions, and then Artemis as well. The intention is for the crew to weigh in on the design and the operations of the vehicle, So I know the administrator said it before, right? We're at headquarters aren't part of the crew selections. That's all JSC, but it's broken up that way in order to get the expertise of these crew members that we're entrusting to fly in the future on the development of the vehicles, and then it's broken out by mission as the crews are named.
Thank you. We'll take your question in the room.
Eric Lipton from the New York Times. Just wanted you to reflect upon the fact that here we're at the 9th flight of the Dragon for the commercial crew program, and March 12th you're talking about having the 30th commercial resupply mission. And just to for the administrator to reflect upon the the routineness of this. I mean, of course, there's always risk associated with every flight, but just reflect upon where we're at in terms of commercial space, providing this role for NASA. If you could just pause and reflect upon this moment we're at right now.
Well, let me take you all the way back to Kennedy's speech at Rice Stadium, in which he said, we go to the moon and do other things, not because it's easy, but because it's hard. Space flight is hard. Space flight is risky. So whether it's commercial or if it's the SLS, which is NASA, the landers, which are commercial, whatever, it's risky business. What you never want to get into is the thrust of your question, which is that it becomes so routine. And that's why at NASA we are insisting with our employees and our contractors that safety is primary. We hammer this home all year, but particularly at the time of the Day of the Remembrance, which is sometime in late January, early February, commemorating the terrible loss of 17 astronauts as a result of a lack of safety. And yet it almost seems routine to the uneducated eye that SpaceX is putting them up one after another. This past year, SpaceX has launched almost 100 launches. I expect that next year they're going to well exceed 100 launches. Clearly, the entry of SpaceX by having the return of the first stage has brought the cost down significantly. That has affected the entire launch industry. We'll be seeing attempts at bringing the second stage down on some missions. And as a result of that, you never want to get into the frame of mind that it is so routine that it's like getting in your car and taking a Sunday afternoon drive. And oh, by the way, that was the frame of mind that shocked the nation on January the 28th, 1986, when Challenger blew up in the Florida sky. The nation was in disbelief because the space shuttle for 24 flights had seemed so routine. That's not the case of space flight.
SpaceX continues to work on Starship, which is, future planned use for the moon landing. As you watched, with their first launch attempt and the damage that occurred there on the ground in South Texas, I mean, that, they're working towards delivering a vehicle for NASA in part. Was that a matter of some concern to you to see the launch pad kind of, destructed and debris blown out into the area outside of the land that SpaceX controlled?
If that were pad 39A, I would be concerned. But this is a whole different way of experimentation and building rockets that SpaceX uses. And they learned lessons. So they redid the pad. They have learned with each of those 3 flights out there. They have 2 flights coming up on the 3rd. They've learned lessons. And that's the history of the Falcon 9. They started out with the Falcon 1, and it'd blow up, and they'd fly it again, and they'd figure out what happened to the first one, and they'd figure it and fix it. And look at what has resulted. They had one either commercial launch or something that blew up after it had, and they realized they had mistakes there. They fixed that, and they've had this enviable record. But every time we launch, it's white knuckle time, and especially if humans are on top.
Thank you so much for your question. We'll take our very last question from Jim Siegel at nasatech.net on the phone.
Hi, everybody. Jim Siegel from nasatech.net. Thank you for taking my question. I was curious about the time that the astronauts are spending with their families and whether they, in fact, at this point in time are still with their families, and when will they say their final goodbyes to each other before the launch? Thank you.
And so this is Joel. I'll start, and then anybody else can add. And so they are still spending every day some time with their families. As you know, we have a quarantine process, and the immediate family has quarantine with the crew members. And as Emily explained after the flight readiness review, we have grades of quarantine for other people that need to do and meet with the crew. So they'll say their final goodbyes up until they leave crew quarters. So when they leave crew quarters, they'll get into the cars and they'll be waving to their family and saying their last goodbyes. And then once they get on orbit, we have a pretty cool capability on the International Space Station where they can make a phone call to their families and actually anyone else they want to call. And so we keep good contact, making sure that the crew members and their families are tied up, not only pre-launch, but during their mission is really important to NASA, and it's something that we've excelled at.
By the way, I'd like to put an amendment to your question. It's not a final goodbye. It's a see you in 6 months.
Well, that's a great way to wrap up for today. I want to thank all of you for joining, thank our participants, and for those of you who asked a question. Shortly after we conclude this morning, you can listen to a replay of the press conference online. Thank you again for joining us. Crew 8 launch coverage begins Thursday at 8 p.m. on nasa.gov/TV and NASA Plus. So we look forward to you joining us, and go Crew 8.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.